Chapter 5, number 41. As part of a physics experiment, you stand on a bathroom scale in an elevator. Although your normal weight is 610 newtons, the scale at the moment reads 730 newtons. A is the acceleration of the elevator upward, downward, or zero, and explain. B, calculate the magnitude of the elevator's acceleration. C, what, if anything, can you say about the velocity of the acceleration, and explain your answer. So, our first thing is really to draw, as always, a free body diagram. So I'm going to represent the person with just a dot and say what acts on this dot. Well, there is the scale holding the person up, and there is gravity trying to pull the person down, and there is an acceleration, which I'm going to choose to go upward, and we'll see if that's right later on. In fact, part A lets me reason about this. If the scale reads more than the weight, and this scale does read more than the weight because it reads 730 even though the weight is 610, then the scale must be pushing harder than gravity is pulling down, and so the object is accelerating upward. So part A confirms my diagram, which is that the acceleration is upward. Second, we can compute the amount by saying that the force of the scale and the force of gravity are opposed, there's a minus sign there, and that's equal to the mass times the acceleration. So the thing we want, the acceleration, turns out to be just the force on from the scale minus the force due to gravity over the mass of the object. Unfortunately, we don't actually have the mass of the object, but we can cheat a little and we can say, well, if I had a g down here, then I'd have just m times g down the bottom, and I have fg, but I can't do that without multiplying the whole thing by a g out front. So this can also be written as the acceleration due to gravity times the difference in forces over the weight. If that makes you uncomfortable, you can just go off to the side and compute the mass by saying fg equals m times g and solve for m. You'll get the same place. All right, if we throw in our numbers, we would have 730 newtons minus 610 newtons over 610 newtons, all times 9.81 meters per second square. So we get 1.9298 meters per second squared, which is really 1.9 because we have only 2 digits of accuracy. That's part B. And part C says, what, if anything, can we say about the velocity of the elevator? And we can't say anything at all. All we can say is that it's changing, but we don't know if it's upward or downward. We don't know its value at the moment. We can't really say anything except that whatever it is, it's getting more upward. So it is either an elevator that is heading upward and becoming more so, or it's an elevator that's heading downward but becoming less so. But we don't know which of those is the case.